Hello there, welcome back. Today we're looking at simultaneous equations and solution by Matrix Determinant Method, and sometimes we call it as Crammer's rule. In our previous video, we look at matrix method, and that was adjoint method. So you can go ahead and also watch that video before you can proceed from here if you wish. And then before we continue with this video, I would like to aware you that at the end of this discussion, I'm going to give you some questions called check-up points. So please go ahead and attempt those questions, then give your answers to the comment section for us to know that you have worked on them. So let's now move on to this video here. How do you get solution of equations or system of equations using Cramer's rule? Now, for example, we have these questions here. The first thing you need to do is to form the matrix equation. After forming the matrix equation, then you get determinant of the matrix of the coefficient of this x and y. After getting that, and then we'll get another matrix which is got by replacing like coefficient of x by this constant, and we also get its determinant. Then we get another matrix with a coefficient of y replaced by the constants here, and we also get the determinant. So for you to get the value for x, we get the determinant of the coefficient of x being replaced by the constant divided by the determinant of the previous coefficient. Then y will be done in the same way, where we get the determinant of the matrix with the coefficient of y replaced by the constant. From there, that will give us the solution. So let's put this in practice in the next page. So in this question, part A of the question, we first check to see that x and y corresponds. And since they're all corresponding, we are good to go. We just need to convert this into a matrix equation. So the first thing is we extract out the coefficient of x, and that is 2 and 3. Then extract out the coefficient of y, and that is negative 3 and negative 4. So you can form this one as also equation. Well, this is our matrix equation. So we can go ahead and extract this matrix of the coefficient, and we can call it D naught. So our D naught is having coefficient of 2, negative 3, 3, and negative 4 as the extract from this equation. And we get determinant, and let's call this one here delta naught as the determinant of this, and determinant can be represented by these straight lines where we have 2, negative 3, then 3 and negative 4. Take note that this one's a straight line without any, that is 2 times negative 4. Then we subtract the product of non-leading diagonal, and that is 3 times negative 3. So here, when you multiply 2 and negative 4, you get negative 8. Then minus into 3 times negative 3, we get negative 9. If we open that bracket up, then we can get our delta naught as negative 8 plus 9. That simplifies down to positive 1. So this is the determinant of the matrix of the coefficient of x and y. Now let's replace the coefficients of x by the constant terms here. So we can go ahead saying replacing the coefficient of x by the elements of the constant of just constants. Now if that is the case, we can call this one here as D1, and this D1 will be X elements here will be replaced by 1 and 3, maintaining Y coefficients which were -3 and -4. So therefore we had a new matrix with these elements. Then we can go ahead and get the determinant of this, and determinant can also be represented by this parallel 5, -3 and 4, and this bar also. Then we can, okay, this is not the determinant, so we can differentiate by having it in terms of delta. Oops, this one looks messy. Let's try to correct it. So delta 1 give us this. Therefore our delta 1 can be got by multiplying the leading diagonal, and we have 1 times -4 minus multiplying the elements in the leading diagonal, 3 times -3, and then this will give us -4 minus -9, then -4 plus 9, and finally we get positive 5 as the determinant of this. Then the next one, also replacing the elements of coefficient of y by our constant term. Now let's do it here and say D2 is got by maintaining elements of the first column and then replacing this by 1 and 3. So I can get the determinant delta 2 is got by 2, 1, 3 and 3. So here our delta 2 is multiplying the elements of the leading diagonal, subtract away the result multiplication of the elements of non-leading diagonal. So our delta 2 will be 6, that is 3, and that is 3. So that is delta 2. So how do you get the values for x and y? Let's look at that in the next page. Let's collect this together, where we have our delta naught with a value of 1, delta 1 with a value of 5, then delta 2 with a value of 3. So remember, delta 1 was obtained when you replace the coefficient of x. So meaning here this one will lead us to get the answer for x. So x value will be got by dividing delta 1 by delta naught. So our delta 1 is 5 and delta naught is 1. 5 divided by 1, we get 5. That is the value for x. Then the value for y is got by dividing delta 2 by delta naught. Therefore delta 2 is 3. Dividing it by 1, y is equals to 3. Then we can check using one of the equation to make sure that our answers are correct. So let's take equation number 1 with 2x minus 3 y equals to 1. I'm also taking in left hand side of this equation. X is 2x minus 3y. We can replace x by 5 and replace y by 3. Then the first one results to 10 and the second results to 9. So 10 minus 9 is 1. Since the left hand side is equal to the right hand side, then our answer is perfectly correct. So the value for y and the value for x are okay. Therefore, when x is equals to 5, then y equals 3. So please, if you have got some good value in this video, consider subscribing, like this video and share with friends so that you don't miss any of my videos I'm uploading on daily basis. Now let's move on to the last number, and as well we prepare for our checkup point. So in part 2, let's also work in the same way, where we extract the coefficient since x and y are already arranged in order. So we have here 2, 3 as coefficient of x, and then negative 5 and positive 2 as coefficients for y. Then we start with the first letter, and that is x. Then the next letter, y. This one should be equals to the constant terms. So we get this element 3 and 14. Then having written this, we can call this one as d1. So the d0 equals to this element 2, 3, negative 5 and 2 as the matrix coefficient of the x and y from this matrix equation. So we can get determinant, we can call it delta naught equals to, now we use this bars, we have here 2, 3, negative 5 and then 2, then this bar, and we get our result of this multiplication through having the leading diagonal. So this time let's multiply directly. 2 and 2 makes 4 minus into 3 and negative 5, we get negative 15. So the negative and negative will vanish to positive, so we have here 15 plus 4 to get our delta naught. Therefore we can reduce it down to 19 positive. Now we can do the same to the next one. To get d1, we can replace the coefficients of x by the constant terms to get a new matrix which will represent x. So we shall have here 3 and 14 and then negative 5 and 2. So we can go ahead also and get the determinant delta naught, that is given by 2 times 3, 6 minus negative 5 times 14, that yields us to 70, but negative, and then negative and negative will make positive, and we have here 6 and 70. When you add the 2, you will get delta 1 as 76. And then lastly, let's get also matrix called D2, that is got by replacing the coefficient of y. So let's maintain our coefficient of x for these elements here by 2, 3, and then replacing this one by 3, and then 14. Then we can go ahead and get its determinant by having delta 2 is given by, we can use now the bars. So we have here 2, 3, and then 3 and 14. So multiply elements in a leading diagonal, we have 2 times 14, and that is 28 minus 3 times 3, that is 9. So we can subtract that directly and we obtain 19, and that is delta 2. So we can go ahead and get the results for x and y. So x, we can maybe collect this nearer for our simple calculation. So we have here delta naught with a value of 19, then delta 1 with a value of 76, then delta 2 with a value of 19. So from there we can move on and get x value, which is got from delta 1 divided by delta naught. So our x is delta 1, that is 76 divided by delta naught, and that is 19. So if we divide 76 by 19, we get 4. Then we do the same to y. So y value is got by dividing delta 2 by delta naught. Therefore, delta 2 is 19 and delta naught is also 19, meaning y value is just simply 1. Therefore, as x is 4, then y should be what? 1, and these are our answers. So after here, let's look at a checkpoint, and please remember to share your answers in the comment section for us to know that you really understood this part and you have worked out the question successfully. So this is the checkpoint. The question is: solve the following pair of equations or simultaneous equations using determinant method or Cramer's rule. This is the same way of saying. Now part A is 3x plus 5y equals to 1, and then x minus y equals to negative 5. That is the first pair of the equation. Second pair is 3x minus y equals to 6. Then 2x plus 5y equals to negative 13. So please share your answer and stay tuned to the channel so that you don't miss out. In the next discussion, we shall look at another method of solving simultaneous equation, and that is graphical method. See you on the other side. Share.